compare the objects, compare the opinions of the respondents, whether they prefer this or that, having only two groups or two categories with multiple categories. And now the second part of that scaling technique is related to non-comparative scaling techniques. Here the primary purpose of using these scales for measurement of the selected variables or the construct is not to compare, only to get the opinion of the respondent or the object at that particular time. So hence the purpose is not to compare within the abstracts or the concepts. Though our purpose is to compare the opinions, but not the construct which we have selected. So that's why these techniques are called as non-comparative scaling techniques. Under this non-comparative scaling techniques, we have again subdivided into the the continuous scaling technique or rating scales and the itemized rating scales. Under this the continuous rating scale, the name itself indicates that the scales are continuous, the scale is continuous in nature, and which is normally in literature referred as the graphic rating scale. Here the respondents rate the objects by placing a mark at the appropriate position on the line that run from one extreme of the criterion variable to the other. So hence here we have only two aspects of that scale. The one is in the left hand side, the other one is in the right hand side. So that criterion divided that aspect or the construct into two extremes. Okay, then the scale run from one extreme to another extreme, and the respondents are not restricted to selecting from marks previously set by the researchers. The form of the continuous scale may be vary considerably. That's why here there is no any free the pre-setting of that, since we are only, or the scale is only having two extremes. For example, like this. How do you evaluate our vote? So in that, probably the worst and the probably the best. So only two extremes. Okay. Then the points is from 0 to 100, and they should have to mark on that line. It is like a graphic scale, because you have a scale represented with this graph. So then the respondent has to mark closer to the right extreme or closer to the left extreme or in the middle. If it is nearer to the middle, so that means the opinion of the respondent is somehow like neutral. But if it is, for example, the mark is towards the left, that means so his preference or the opinion is relatively towards, it is worst. Or if the mark is towards right, so he prefers, that is the best related opinion he has assumed to be or expected to be given. And one more is, how do you compare Coca-Cola with the Pepsi? Earlier, whether he prefer or not, like that. But now in this continuous scale type of rating, so here we have only the two extremes. The one is totally different, and both they are one and the same, totally same. That is related to the taste or other qualities related question if it is. So then whether they are having any difference or they are one and the same. So like this continuous scaling or the graphic related scale is like in a graph form. So only two extremes are given. So the respondent asked to mark in this given scale. So hence it is called as a continuous itemized scale. Then the last but not the least, and of course the most probably applied or using scaling technique related to this non-comparative scaling techniques are the itemized rating scales. Under that, here we have the three. One is Likert scale, semantic differential scale, and the Stapel scale. So the first one is the Likert scale. Again, out of these three, the most popular and most widely used tool is the Likert scale. Okay, this is the widely used rating scale that requires the respondent to indicate a degree of agreement or disagreement with each of the series of statements about the stimulus objects. So here only the opinion of the respondent has been collected or have been collected, and most of the opinions are related to agreement of the respondent or disagreement of the respondent related to the options given to the respondent. And typically each scale item has 5 response categories ranging from strongly agree to strongly disagree to strongly agree. So there are some, this is the 5-point scale is again most popular within this, and also there are 7-point scale, and that is depends upon the researcher to classify the options regarding that particular question. So that's why I strongly disagree, neutral, agree, strongly disagree. So these are the constructs or the concept that has to be developed by the researcher, and out of these 5 options given to the respondent has to select only one. So hence there is no comparison among these. Only one option has to be selected by the respondent, and hence it is non-comparative type of scaling, and it is related to item because the items are given by the researcher to the respondents. So this is the Likert scale, and of course if you take one example related to that, a question, of course it is a question. Okay, it is a scale which measures an attitude or the behavior. That means you have a question. So that question is normally related to the attitude or the behavior in case of marketing related research. Example, so like this. Here the opinions are listed below about the decisional bank. Opinions of the respondent related to this bank. Please indicate how strong you agree or disagree with by putting a tick next to your choice on the following scale, and there are 5, this is the 5 scale Likert scale, and these are related to, the one is related to the quality. Okay, one is related to the quality of the services, the other one is the operational support, the third one is so related to the conduct of transactions, and the other one is does not have good European network, branch network, electronic banking security of this bank is terrible. So these are the questions. This need not be only 5. You can have any number of questions related to the performance of the bank or the attitude of the staff or the other aspects. So then each of these has 5-point scale, or the opinions are measured in 5-point scale from strongly disagree to strongly agree. And another important point which we should have to bear in our mind in this Likert scale and other types of scale, especially we will make use this information for summing, counting, and also for some descriptive type of analysis of, say, using arithmetic mean for this, because we can also use arithmetic mean, but not for the others non-comparative type of scales, because they are not ranked. Okay, so see, since there is an order here is that, so you can use arithmetic mean. So for using the arithmetic mean and also for other appropriate statistical tool, so you should have to assign the number starting from 1 to 5 for disagree to agree. Disagree to agree. So statistically or mathematically you can reverse the numbers. No difference in that. But for our analysis purpose, so you should have to assign the numbers like this. So highest number should be towards agree. Because, for example, if I calculate the arithmetic mean related to this, the bank delivers high quality banking services. So then let us assume that you have 300 customers and get opinion from these 300 customers related to this variable. So then I can count or estimate the average. So that is the 500 opinions, they are in numbers, divided by 500. Okay. For example, that gives me the average arithmetic mean gives me 4.5. 4.5. Okay. So then that 4.5 indicating the preference of the consumer or the satisfaction or the agree as related to this particular variable is since closer to the 5, then the opinion of the customers related to the high quality services is good. That means the quality, that is the service provided by this bank is high quality. That is the final conclusion. If the calculated value is less than 3, for example, it is 2, 2.2 or like that, or 1.5, so then the services provided by the bank is poor. So that's why if you reverse this, instead of 1, 2, 3, 4 like this, 5, 4, 2, 2, 1, so then you might have to interpret the results in the different way. So that's why in assigning the numbers for this type of qualitative variables or this for Likert scale analysis, so better to give a lesser number for disagreement related phenomena and increase your numbers. So this is the way which you should have to assign the numbers for the Likert scale. And here it is agree or level of satisfaction or job level, so on the education level. Like this you can use this Likert scale wherever it is possible for your variable can be measured in ordinal form. That's why for all those ordinal variables, so you can make use this Likert scale. Then sample Likert scale question like this: rate each item on the scale should indicate your level of agreement. Like I believe in the Bill of Rights. Then, so I think that everyone should vote, or no politician cannot be, most politician cannot be trusted. So like this, so you can have several such examples where you can use these types of opinions related pool or opinions related questions, and those opinions can be classified into these Likert scale related, and some more examples. Okay, it is related to job depression related aspects. Okay, this is related to Likert scale. And also by making use of that Likert scale, probably if you go through some statistics books, earlier as I have told you that the books related to multivariate statistical tools, there are some books, multivariate statistical tools. So the regression analysis and other types of advanced statistical tools are also used for these types of Likert scale related constructs or the measurement. The next one is semantic differential scale. This scale is 7-point rating scale with endpoints associated with bipolar labels that have semantic meaning. In a typical application, respondents rate objects on a number of itemized 7-point rating scales bounded at each end by one of the two bipolar objects such as cold and warm. So here again, as earlier we have seen in case of continuous scale, this is also a bipolar one. But that within that bipolar you have 7-point scale. For example, like this. Like here again it is related to that band. So the following descriptive scales bounded at each end by bipolar adjectives, summaries, characteristics of the band. They is marked with that symbol, the blank that indicate what the band means to you. So like this: powerful, weak, then unreliable, reliable, modern, old-fashioned. So like this, these are some characteristics. So you need information related to those characteristics with bipolar. Whereas in case of say the Likert scale, you have a number there, 1 to 5 or 1 to 7 scale. Whereas in case of semantic, so it is like only you have to mark with only bipolar. That means you have extreme values values. Earlier also we have an extreme values in case of continuous one, but it is a continuous one from 0, 1, 2, 3 like that, 10 like that. But there is no such numbers in case of this differential scales. So only a bipolar scale type of examples. And this is one more like different scale for self concepts, personal concepts and product concept like this. So but delicate, excitable, calm and so on. So like this you have extreme concepts, bipolar concepts, and there you should have to mark this whether towards the left polar or to the right polar, or left extreme or to the right extreme. Okay, this is about the semantic, and the last one is the Staple scale. Okay, it was invented by this Staple and named after this developer John Staple, and it is a unipolar rating scale with 10 categories numbered from. So it is a unipolar. Earlier that was a bipolar one. It is a unipolar and 10 categories. So you have some positive attitudes. So and you need to measure some negative attitudes. Okay. So if the opinions are related to positive related attitudes, positive preferences or so on, then you should have to ask to assign the number from 1 to 5 towards positive values. Or if it is negative, related to the negative aspects, then -1 to -5. That's why it is a 10 categories which are numbered from -5 to +5. And earlier probably you have seen all of them are in horizontal form in their representation, but this is in vertical. And for example, here the respondent are asked to indicate scaling an appropriate numerical response category, how accurately or inaccurately each term describes the object. Higher the number, more accurately the term describes the object. So, okay, these are the instructions you should have to give to them. And for example, like this, it is related to again that, and it is one is the quality related aspect, the other one is the per service. So then like this, you should have to earlier specify these numbers. Okay, -1 to -5, +1 to +5. For example, there is a one respondent given his opinion like this. Related to high quality, it is -4. That is the quality of the service provided by this bank is very poor, which is very closer to the highest number, okay, in negative form. Whereas in case of the poor service, it is positive. Poor service providing positive means it is poor, service is poor. So since the high quality is negative, naturally the service is poor. So that's why in some of the cases, since the respondents have not much knowledge about this, if you ask somebody or if you have given your questionnaire to some enumerators or your student to get information related to this, so then some respondent might think this and this. So the opinion is contradictory. Why it is contradictory? Because so high quality, if it is negative means the service is poor should be positive. That's why we must be very careful regarding, because in some of the cases, for example in our subject, so in majority of the cases, okay, especially related to standard of living related aspects, the opinions which we get from the respondent from the field is contradictory. Say for example, if I ask a question, a more sensitive one, in case of economics, is related to the income. So if I ask a question related to the income, and all of you in your admission process of your students, probably you have seen the income of the household or income of the parents, that starts from 10,000 rupees, 11,000 rupees and so on. So like that, so if we ask a question related to what is your total income, family income per year or per month. For example, per year they state only 30,000 rupees, 20,000 rupees. But if we ask what is your wage per day, if an agricultural labor, he say 400 rupees. So wage is 400 rupees per day, but per year income is 11,000 rupees. So these are the contradictions which we have seen. So the same kind of contradiction might be even observed even with our collection of the data for these types of scales. So we should be very careful regarding this. Okay. So this is about that scaling techniques, and of course I don't want to get into this. This is the reliability and validity, because we should have to validate our information which we have gathered through making use of this measurement aspect, and also we should have to check or to test or to retest, okay, the reliability of our collected information. So there are of course techniques, there are statistical techniques. Probably you might have been, some of you have heard Cronbar test, Cronbar reliability test. That means by making use of that, we can test whether the information which we have collected based on this Likert scale or any other type of scale is reliable or not. And also we need to validate. So that means the validation means what we wish to collect from the respondent, and we should have to compare with what we have got or collected from the respondent, whether they are matching or not. So that's why we should have to also validate that. So without reliable, so if that information is collected is not reliable, for example, earlier I have told you that that is the income, which is not reliable, then how to overcome from that problem? So probably the investigators were suggested that, so then instead of asking a question for the respondent related to the income of the households, then you better to ask their consumption expenditure, how much you consume on food, how much you consume on other aspects. Probably that is a better measure compared to the income, households income. That's why there are some alternative methods. We should have to make use that alternative methods. So then what we are expected or wish to collect is somehow nearer to what we have collected. That is validation. That's why there are techniques, we need not get into that. Okay. This is about the first part of our discussion. Okay, the next is sampling technique. As earlier I have told you that this part or this content is also a part of methodology of the research work. So in the methodology of any research work, probably that start with data sources, whether our research work is based either both on primary and secondary data, or only on secondary or only on primary data. So if it is only on secondary data, so then this topic doesn't come. It doesn't mean that, so this is not important, because in majority of the cases we know that for an investigator we make use both primary and secondary data. So if it is related to the secondary data, so primary data, then we should have to identify the area of investigation, geographical area of investigation. So then we should have to determine the sample, and why of course we need sample, why we need to have a knowledge of these sampling techniques. So there are separate chapters in statistics books related to this sampling techniques, sampling distribution theories, and so on. So after this probably we have a concept like this sampling techniques. So when a researcher is unable to get information from each and every unit of the population or the universe of the study, then we should have to rely on sample. So the most important the advantage or the reason for using sample instead of collecting information from the universe or the statistical population is to avoid cost or to reduce cost, and also to reduce time for the collection of the data, to increase accuracy of the information. So, and also the other important advantage of this sample over census method is that, for example, if your purpose, probably all of us knew that there is a quality control department in all the organizations. So the purpose of that quality control department is to check the quality of the product. That's why on every product there is a seal. Okay, that seal is related to quality control. That is, the quality of the product is checked before marketing of that particular product. Okay, the purpose of the quality control department is to test the quality, whether in terms of its weight. For example, let us assume that it is a pharmaceutical company. Okay, that pharmaceutical company is selling a syrup, for example. Okay, that syrup should contain some specific chemical compositions. So I don't know, since I am from economics, I don't have any knowledge related to that. So your purpose is to check the weight of that bottle. So there is a production process. That production process has to fill only 100 ml to that particular bottle. Only 100 ml, not more than that and not lesser than that. Okay. So there is some variations. It might be 2% or up to 5% is tolerable. I hope you know all those things. Okay, in terms of the quality variations. So if then for that purpose it has to be tested or checked back. So therefore there we should have to check the weight of that. So let us assume that the company producing 1 lakh such bottles per day. 1 lakh bottles per day. So if it is a census method, then to check the quality of that filling of that syrup into the bottle, then the company has to check every bottle. It has to open every bottle and measure it and check whether the machine fill exactly 100 ml or not. So then what happens? What is the implication of this? It cost, time, the number of the persons or the staff required for that. So then it is impossible in practical sense. So the one more example. So a company is producing a glass item. It has to test the quality of that. So to test the quality, the glass has to be. So if every glass has to break to test, then it is obstacle. That means it cannot be followed. This is another important advantage of why the sampling has to be used. And if you come to our own case, if my purpose is to evaluate a particular program, for example, the Swachh Bharat mission, Jal Jeevan mission, or any such program either of the state or the central government. So if I take Karnataka, for example, or Rait Sanman Yojana, or that is Kishan Sanman Yojana, like that. So to my knowledge, in every village there might be 100, 200, 300, in some village 500 Raitas, or the farmers are the beneficiaries of that. So if you take Karnataka level, then lakhs of farmers are there. So if my purpose is to measure the performance of that, then as an individual with my limitations, I am unable to contact all those farmers. So then I have to select only few farmers, a part of that population, and of course, there is, as earlier I have told you that there is a theory in statistics, so that is the sampling distribution theories, the theory of large numbers, central limit theorem. So based on all these, statisticians developed these sampling techniques, where these sampling techniques provide you the same kind of results which we will obtain if the census is used. There is not much difference between these two. Like that, there are several advantages in using sampling techniques in all surveys. So that's why majority of the investigations, research works are make use of sampling techniques. Probably I hope all of us knew that though the Indian government or the census register was, or that department was collected information from all the households in 2021, yet even after 3 years the full census report was not published. So as a government is unable to get information from all the households, it is impossible for a person. So like that, there are several such advantages. So for that purpose we need sample. And the next questions are, so then because of these regions we should have to select a subset of the population, a sample from the population. The next immediate question is, then how do we select a subset, a part from the population? Probably these sampling techniques help us in that direction, how we should select a representative sample from a population, and the discussion related to these sampling techniques probably will answer for that particular question. So as just I have told you that it is a process of selecting a sample number of elements from a large defined target group of elements such that the information gathered from the small sample groups will allow judgment to be made about the large groups. So for any researcher, the knowledge of statistics is inevitable. Without having the knowledge of statistics, of course we cannot do research work. And there are like your own discipline, the statistics has also divided into different branches. The statistics has two broad branches. The one is descriptive statistics, the other one is inferential statistics. So these are all the contents which come under inferential statistics. So the purpose of that inferential statistics is this. So why you have selected a sample? So you have selected a sample because of the reasons just we have noted that. And your focus is not on the sample, because whatever the results you will get, that results will be only from your sample. But your basic primary purpose is not to study about that sample, but your primary purpose was about the population, because in majority of the cases, even in thesis evaluation, I have seen that the conclusions, inferences, results were written by the students based only on sample evidences. For example, they have selected 500 samples. So based on the results of the 500 samples, they have derived conclusions, derived inferences. But that is not correct, because you have not tested. So whether the results you have obtained for these 500 households, respondents, objects, or whatever it is, whether it is similar to the larger group, population or not. So hence, that inferential statistics has two branches. The one is estimation, the other one is hypothesis testing. The estimation is obtaining the numerical results for your sample values, and the hypothesis testing is comparing your sample results with unknown population results. So that's why without having that knowledge of statistics, that's why our knowledge of research is not complete. So I don't want to get into all those things, since this is a discussion only related to, because this topic needs the knowledge of all those statistical background. So this is just all of you are familiar with this. So that is, your focus is on a study of group of objects, that is universe or population. So then all the, for example, if your purpose is to study about the performance of banks in Indian context, then all the banks in India are your objects or the elements. So your purpose is to study about the consumers related to a particular product, then all the consumers of that product are the element of your study. So then you have to define target group. But out of that, your purpose is not to study about that whole elements of the population. You might be selected only a part of the whole population. It is not a sample. So your focus is only on that. For example, if it is on age group, so your purpose is to focus only between 18 to 45, the age group of the people between to 45. Then the target group is between 18 to 45. So like that. So then the sampling unit. So after that you have to identify the sampling unit. So then you should have to have a sampling frame for that. If the information related to that sampling units are available. If the units of the samples are not available, then it is very difficult for you to frame the sample or sampling frame. For example, earlier I told you that. So if you get into that dashboard of Kisan Samman Yojana, the beneficiaries' names are available in that. So based on that, you can have a sampling frame. So if the list of beneficiaries are not available, then it is very difficult to have a sampling frame. And this is another important concept, that is, since the information which we will gather from the field or from the respondent is only the part or the subset of the population, always there is a difference between the true value. The true value means the value of the population units and with the value of your sample, value of the sample. So hence there is an error between the population value, sample value. So for example, if I take the Kisan related Samman Yojana and its performance, if I selected only 500 persons as my sample units, and if there are more than 2 crores of say farmers in Karnataka, so then naturally there is a difference between the opinions of the 2 crores farmers with this only 500 farmers which I have selected as my sample for the analysis. So hence always there is a difference between this, and this is a bias attributable to mistake either drawing a sample or determining the sample size. So that is, that sample error occurs in terms of drawing the sample itself. That's why earlier I told you that the sample should be representative. If the sample is not representative, so then the results which you will get from the sample cannot be represent the characteristics or attributes of the true population. So that's why the sample should be a representative sample. If the sample is not representative, so we make a mistake or a bias in selection of the sample itself. So that leads to sample error or determining the sample size. So there are scientific methods in determining the sample size. So again to this, in majority of the cases, so if we ask a question related to a researcher, how do you arrive at this number of sample size? So no answer for that. So for example, you are saying that the sample size is 400. Then what is the justification to get this 400? Is there any rule for that, or you have used any statistical rule in determining the sample size? So in majority of the cases, the students speaking, that is the research students, so they are not having answer. That's why if the sample size is not appropriate, the sample size is not, say, suitable to the total population, so then we also have mistake. So then the sampling error, and of course we can reduce this sample error by increasing the sample size. There are different techniques for that. I hope you are familiar with that. So that's why in sampling analysis we should have to keep this point in our mind, and never samples error is 0. So when sample error is 0, only when your investigation collects data from every element of the population, and this is the sample plan. So I think you are so familiar with that. You should have to define your population of interest. So then the Kisan Samman Yojana, then all the farmers are who are beneficiaries of that or the population. Yes,
But if the population size is around 2 crores, what would be the standard sampling
So,
area?
okay. So there is a formula for that. So there are broadly that has been classified into two. One is the sample size determination for finite population and the infinite population. So yours is finite population. Instead of using that infinite, you have to use that finite population. There is a number n there. In place of that n, you should have to write 2 crore. That gives you the appropriate size.
So if a number exceeds more than some like 50,000 or then is it possible to have a
No, not necessary. So that's why early, that is a pure rule based on the determination of the sample size. But there are theories. That's why I told you that. The theory is called as the theorem of large numbers, the central limit theorem. Okay, according to those theorems, so if your sample size is large enough, so then your sample follows the normal distribution. So there are different distributions. Probably all of you knew that. There is for all the statistical distributions, the mother is normal distribution. Your chi-square or the f or the binomial distribution or any that is gamma distribution. So semi-normal distribution, like that there are more than 15 distributions to my knowledge. Okay, so all those distributions approaches to normal distribution. So that's why even for example, if you calculate a sample size for infinite population, so that gives you 384. There are some tables given by the statisticians. So the number of the sample size for a given number of population. We can also use the tables, So that's why, say in some cases only 300, 400 are also been used. Whereas in case of marketing analysis, okay, so 900, 1000 has also been used. So but though your statistical tool or that is the sample determination rule gives you a lesser sample size, but you can use more samples because might we have seen that there is a diagram related to the sampling error. Sampling error decreases with increasing sample size. So that's why. So to decrease the sample size, that is the error, bias in our analysis. So we can increase the sample size. And along with the statistical rule, the other criteria are the time which is available to you, the task which you incur to collect the information. And these aspects are also as important as your statistical rules. That's why by taking into this statistical criteria along with these practical aspects, we should have to decide finally the numbers of the sample. But it should not be less. If it is less, so the results are not much reliable. So only because of that, so we should have to make use that statistical rules to determine the sample size along with these common sense related aspects. So we need not get into this since my topic is on related to sampling methods. So then, okay. The methods of sampling are broadly classified into two: random sampling and non-random sampling, which is also known as probability sampling and non-probability sampling. So probability and non-probability sampling. So the probability sampling means, so the procedure of drawing a sample unit from the population is based on the rules of probability. rules of probability. So the probability is also a statistical tool, and earlier I have stated that inferential statistics, all the tools of inferential statistics were based on probability theories, and more specifically they are also called as mathematical statistics. Probably you have heard about that. So that mathematical statistics is nothing but this inferential statistics, which are mostly based on probability theories. So under this probability sampling technique, each population element has an equal chance of being selected or included in your sample. There is no any bias, human bias more specifically, in selection of the sample. And that is the equally likely. So this is one of the property of that probability. Equally likely means the chance of occurrence. For example, a simple example, tossing or flip a coin. So occurrence of head and occurrence of tail, they have equal chance. Similarly, selecting a sample unit from the population or element from the population, all the units of the population, all the elements of the population have an equal chance of being included in the sample. That is the crux of the probability sampling. And non-probability against to that. So there is no equal chance of being included in the sample for the population. It is based on other criteria, might be on convenience, might be on judgment, and so on. So this is the difference between probability sampling and non-probability sampling. And within this broad classification, there are different methods of probability and non-probability sampling are there. And under probability sampling methods, the first one is the simple random sampling method. The second one is systematic random sampling method. Then the stratified random sampling method, cluster sampling method, and also multi-stage sampling method is also there. And whereas in case of non-probability, the most important methods are convenience sampling, judgment sampling, quota sampling, and snowball sampling method. So these are the important sampling methods under probability and non-probability, are random and non-random. Why we call probability sampling also as random sampling method? The random means unforeseen. That means priori, that is not known. So that is called as random. Of course, again with the basics of the probability, there are fundamental elements in the theory of probability. Probably the first fundamental element is experiment. Random experiment. If the results of an experiment known priorly before conducting the experiment, then you need not to conduct that experiment. Why we should have to treat our research investigation as a random experiment? Because of this, before conducting your research, the results are not priorly known to you. Hence, you should have to treat your research work as a random experiment. That's why there are several fundamental concepts which are so essential to understand to do the research work. So that's why it is also called as random. So priori not known who will be selected in our sample. Hence, it is random experiment, and that is non-random probability. And this is a simple one, simple random probability method. So under which the units have equal non-zero chance of being selected, as already we have noted. So under this method, under this is a simple method, and under this method you should have to have a list of elements. You should have to have the list of the elements within that list of the elements you should have to choose. For example, if you use telephone directory, in that telephone directory you have a list of customers, and based on that you can select one, or you should have to have, okay, given a number or a name for those respondents or the objects of your study, and you should have to put that tick in the bow, and you should have to pick randomly, and within that picking up that tick representing the objects or the respondents of your study, the one is the replacing and non-replacing. So there are different methods within that, and the simple one, this is a simple one. And also probably you might have seen that there is a random number table which is available in statistics. Random number table. For example, it is only a small one, then only 100 persons, 50 students, you can write their names or given some numbers for them and use that method. So if it is, you have a large number, 10,000, 20,000 in the population, so you have to use that random number sampling, random numbers sampling. So there you should have to pick the numbers. So based on, so 2 digits, 3 digits, 4 digits, like that. So there are some techniques within this simple random method, but to make use of this, as already we have noted that you should have to have a list of that. Otherwise, you cannot use this method. And the second one is systematic random sampling method. So there is a systematic procedure in selection of the sample unit from the population, and in selection of this, okay, you have a, for example, targeted population or the population of your study which is ordered, and the sample is selected based on the position using a skip interval. Probably you have seen that first one, 10th one, 20th, 30th, or 4th, 8th, 12th, 16th, like this, 16th, like this. That means there is a systematic way of selecting a sample unit, but to make use this, again you should have a list of that, and that the objects are, or your respondents should be ordered. Okay, so and hence it is called as a systematic probability sampling technique or systematic random sampling technique. But again, to make use of this systematic random sampling technique, you should have to make a ordered list of the units of the population. So based on that only you should have to use this method. So earlier I have told you that if the respondents related to the Jal Jeevan missions are available, then you have a list. Say in a village, for example, there are 500 beneficiaries. So you need to select only 50 beneficiaries from that 500 beneficiaries, because you cannot select all 500 beneficiaries from a single village. So therefore you need only 50 beneficiaries from that village. Then how to select them? By making use of this systematic, since the list is available and the list is from 1 to 500 persons of the households. So then you should have to make a systematic, okay, arrangement of these beneficiaries and select, so 1/50th or so on like this. Then the third, then this is the steps given that as already we have noted that we should have to have a list of that and determine the number of the unit in the list. You have to determine whether you should have to start to select with the second or the third one or the fifth one. From that you should have to identify an interval. Based on that interval, you should have to select all the numbers of the units you needed for your study. So then compute the skip interval, determine a random start point, and beginning with that and select all the numbers which you are required for your analysis. That is a procedure which you need to follow in case of that systematic probability sampling method. Then the stratified random sampling, this is the third method. Okay, as earlier we have noted that the sample units which we collect from the population should be representative of the population. So because of that reason, so if the sample units or the population or the respondents are not uniform, are their characteristics. Characteristics means, so the construct or the concept which you willing to investigate investigate. So if that is not uniform, similar, identical, or in other words, the respondents or the objects of your study are not identical, so then the earlier methods cannot be used directly, because there is an heterogeneity in the characteristics. If there is an heterogeneity in the characteristics or your focused characteristics, so then you should have to divide your population into strata, groups. So then you should have to select a specific number of sample units from each stratum, each group. So that's why the strata means groups. So and hence it is a stratified random sampling. For example, if my study is related to study about the purchase of a particular product in Big Bazaar or in Reliance Market and so on, related to the preference. So and we know that so that product is, if the product is only purchased by the persons and the age of above 60 years, then you need not to use this. So if the product is purchased by the consumers of all the age, then their preference might not be same. So then you should have to have a sample units from all the ages. So for example, from 18 to 25, 25 to 40, then 40 to 50, 60 and above like this. Because the preference might be difference related to that product based on the age, and also might be difference between the gender, the preference of the product, difference between the gender. That's why you should have to divide your population into two strata. In this case, more number of strata in the earlier case, and hence we need to use, or in that particular context we have to use this stratified random sample or some. It is not an example. It is a simile like this. So which means, so if let us assume that you are cooking only rice. Okay, to check whether it is cooked or not. Okay, you just take 1 or 2 units of that, and finally, or your mother or yourself now, so decide whether it is cooked or not. So that is uniform, because the characteristic of that rice is uniform. You need not to check every unit of that. So instead of that, so if mix 2 things, so rice with ragi. So then just based on checking or testing rice, you cannot say that both are cooked. Okay, or again you mix jowar with that, or like that. That means which indicates the characteristics, attributes are different, heterogeneous. That's why earlier I told you that if your population is heterogeneous, then the best technique is, sampling technique is stratified random sampling technique. And also we should have to bear in our mind, though for our theoretical aspects, we have a discussion, or given in statistics works independently, differently, these different methods, but in practice, it doesn't mean that you should have to use only one method. In practice, we need a mix of this, because if you use this stratified random sampling, and if the population is divided into stratum, so then within a stratum, you should have to select a unit based on other methods, because the stratified random sampling method not give you information related to how to select a unit from the stratum. So for that you should have to either go to simple random sampling method or systematic sampling method. So that's why, so though theoretically as a concept or the tools they are different, but in practice we use an appropriate mix of all these methods. Okay, this is about the stratified random sampling techniques. So this is the steps just I have told you. We have to say divide the population which is heterogeneous into homogeneous group. That is another important part. So there is a difference, heterogeneity across the strata, but within the strata or stratum, the quality or the attribute should be same. That's why you should have to divide your heterogeneous population into homogeneous strata. Homogeneous strata. Then the second one, draw random sample from each stratum. So then the third one, combine the sample from each stratum into a single sample of the target population. Though you have selected, for example, 50 from one stratum, 80 from other stratum, 100 from third stratum, but the total sample size is sum of all these three from the target population. So that is about the stratified random sample. And the one more is cluster sampling. So this is a technique used when natural groupings are evident in a statistical population. That is, so we can able to group our target population. Okay, that is the clusters. So if we are able to cluster the target population based on some criteria, so then we can use this cluster population, and it is often used in marketing research, divided population into comparable groups. So like schools, cities or so on, clustering sampling is to reduce the average cost per interview. The technique given more accurate results when most of the variation in the population is within the group. That means you have to make clusters, you have to make groups, So within that group, again you should have to select, and each cluster has again some particular homogeneous characteristics. That is called as cluster grouping. And the multi-stage, so which is not there. The multi-stage is, you have different stages. So for example, your primary objective is to study about the Karnataka SLO. Then you have selected only 2 or 3 districts. That is the first stage. This is the second stage. Within district, you have to select a few taluks. That is the third stage. And from that, you have to select Hobli and villages and respondents. So that means the sample has been collected in multi-stages. So hence that is called as multi-stage random or the probability sampling. And the non-probability sampling methods are, as already we have noted that. So of course, in some specific cases, specific circumstances or contexts, it is not possible to use sampling, that is the probability or random sampling techniques. Then we can use, or we should have to rely on the non-probability sampling. So under that, the convenience, and if the sample selection and the collection of the information is convenient to the research question which we have selected, then we have to use this non-random or non-probability random sampling. Then we need some judgments. So when the information is not able to obtain related to our research question, or historical prior information is not available. For example, introducing a new product into the market by a company. So there is the decision by a company is to introduce the new product. So to introduce the new product, regarding that new product, the opinions cannot be collected from the consumers because they doesn't have any experience with that new product. Then how you can, because in other related, if the product is existing, it is selling, and for comparison purpose, referring this with other product or other company's product, so you are able to get information from the market. But if the company introduce a new product, then the prior or historical information is not available for that. So then, based on the experience of the CEO or the marketing manager and his opinion, his experience, so he can take decision, judgment. So based on that, we can collect the sample. So then the quota sampling emphasizes representation of the specific characteristics. So in case of quota, again the list is not available or it is not possible to get the random sampling technique, again we are able to divide the population or the target group is into some group, and we can fix the sample unit or the quota for the each group, and hence it is called as quota sampling method. And the snowball sampling method, that is related to when the population itself is very small or the available sample from the particular research investigation is very small, very small. So in such a case, or the information related to the persons or the objects for the investigator is unavailable. So then in such situations, the researcher can say make use of this snowball sample. So which means that, so first interview a person and get information from him related to the constructs or that is the questions of the questionnaire, and ask himself, that is ask the same respondent regarding the next unit of the sample, That's why, so if the information related to that sample units are not available, not known to the investigator, then in such situation he has to use this snowball sampling method. So they are of course given in brief in this case.
Sir, what is the difference between stratified random sampling and quota sampling?
In case of stratified random sampling, pure systematic and probability related rules have been used there. For example, so based on heterogeneity, we have to divide the population, and within the each stratum, selection of the sample units should be based on again randomness, or whether you use systematic or simple random sample. There is no such rules in case of quota sample. You have divided, and you based on the intuition, based on the experience of the researcher himself has to decide or herself has to decide quota for that. So the three groups have been divided. So from each group, how many sample units has to be decided? Determined by the investigator. There is no rule for that. So that is the difference between quota sampling and stratified random sampling method. Okay, these are the things which a researcher needs to careful in selection of the sample from the population. That is, of course, every act of a research in research should be related with objectives of the study, isn't it? Whether it is related to selection of a measurement scale, selection of a sample, selection of a statistical tool for the data analysis, and all aspects, all activities of a researcher in any research work is first should be related with research objectives. So, and we have objectives, we need to meet that objective. Research, so in any research work, the researcher has to meet that objectives, isn't it? So to meet that objectives, he or she has to have a framework. That framework to accomplish the objectives, to meet the objectives, is the methodology. So why the research methodology is so important? Because you should have to describe, you should have to explain everything, how you reach your objectives, how you accomplish your objectives. Whether to accomplish your objectives, we need data. So then how do we collect data? So once the data is collected, so then how you proceed with tabulation and so on. So they all comes under analysis, data analysis. That's why every act of a researcher in all the stages should be linked with objectives. Even in selection of the sampling techniques, so our sampling techniques should be related to objectives of the study. Then, as already we have noted, that resources and the degree of the accuracy. So the degree of the accuracy, as already I have told you that whether the information which we have collected is accurate or not. If the information which we have collected is not accurate by selecting a sample size and the sample units, so then the results are misleading. Results are misleading. So why they are misleading? Because the sampling technique which we have selected is not suitable to the population, hence all the results are misleading. So due to because of inaccuracy in the selection of the sample technique and also selection of sample units from the population. Then
Is it like more the fixed size of the sample size and accuracy is more?
accuracy, no. Accuracy is not related to the sample size. So it is related to, so like for example like this, if you have collect or if your work is a census work, that means collecting information from all the objects of the population. So in such a case, the information is indirectly collected. Indirectly collected means there are enumerators. So by making use of the enumerators, the information is collected. So and hence there is a gap between the actual respondent and the researcher. So therefore, the information which is gathered by a third person might not be as expected as by the researcher or the investigator. But in case of this sampling analysis, according to that statistical analysis, the researcher has to direct control or the direct contact with that, and himself, he or she has collect the data from the respondents. So then the information collected is more accurate compared to population or compared to survey or the census method. So that's right. So according to statistical analysis, the information collected from the sample analysis is more accurate compared to census method because it is two use. There and also the measurement errors are large in case of census method, whereas the measurement methods are less. So due to because of the differences in the bias or the errors, so the sample informations are more accurate compared to census information. That is the statistical sense. But if you increase the sample size, the sample error decreases. Reliability increases. And the other one is time frame, because you should have to decide whether you need only 3 months or 2 months or you need 1 year to collect the data based on the sample size and so on. That is another aspect which you should have to be considered. Then the knowledge of the target population. We should have to have the knowledge about the population. Without having knowledge about the population, probably we cannot say group the population or make the stratum of the population and so on. Okay, then the research scope. That is the scope of your study. So related to that, so I have also heard and also I have seen, especially the PhD students, so they have collected bulk used data. So out of that, when they are analyzing, so they of course only 30%, 40% of the data is useful for their purpose. Remaining say 50 or 60% is, it doesn't mean that it is not related or not useful, but related to their objectives, that is not needed or required. Because I also heard some guides or telling their students that, so you just collect the data, so then out of that we will make use, which are the data which is useful for us. So that's why I have seen that, so 20%, 30% in some cases, in general is waste. That means time, wasted cost incurred for that. That's why based on the research scope, we should have to select our sample size. Then the statistical analysis needs. So that's why, as already I have told you that, so we also, for example, between the probability sampling and non-probability sampling, as all of us knew that, so the probability sampling, as already we have noted that, it is a systematic and scientific method of selection of sample unit. When it is a systematic and scientific, the most of the statistical tools are appropriate for that. Whereas for non-probability sampling, so probably I think you have heard that you cannot generalize, but generalization is possible for the techniques which are used under or comes under this probability sampling. Generalization means, so what you have been observed for the sample units is also equivalently true for the population. So that is called as generalization, inference, conclusion. So this is possible only for probability sampling method, not for non-probability sampling methods. Okay, I think this is about a brief discussion on the two concepts, measurement and the scaling techniques and the sampling techniques. So of course these are the foundations. So if these foundations are strong, then your results are believable, your results are reliable, and also we will get good results. Our work is good. So if these are weak, then of course you know the implications of it. So with these words, so I stop my lecture.
Sir, what's the difference between a cluster and a stratum?
No,
Difference between a cluster and a stratum?
cluster and stratum. So the cluster is, for example, like normally we have used, that is in case of say there are methods in statistics, clustering, like multidimensional scaling and cluster. Based on a single characteristics, a group is classified. For example, based on age, based on their gender, based on their, say, the education level, based on the location, they are classified into some group. Okay? Classified into group. That's why in making use of that cluster method, the criterion are few. Criterion are, you have to take one or two criterion and make clusters of that. Clusters of industrial cluster, probably you have seen. So in case of that industrial cluster, IT cluster, only IT industries, or manufacturing cluster. So that is the criterion are only few. Whereas in case of stratified random sampling, there is no any such specific number of criteria. It is generally heterogeneous. So that heterogeneity due to because of any numbers of variables or any number of criteria. So that is a small difference between the cluster and stratified random sampling method. So I hope that, so of course this is only 2.5 hours lecture. We need to complete these two topics. So it is only a brief in discussion. So my request is you should have to go through the statistics and moreover that for doing any research work along with reading statistics books or research methodology books, the best way of learning is reading empirical works. Reading empirical works. And moreover, reading articles not in journals. I don't need to say that those names of the journals. So you should have to read the journals which are truly referred, because there are names for the journals. Probably you have seen the names are refereed journals. So you know that, for example, in case of agricultural economics, there is a journal of Indian Agriculture Journal. So they have not mentioned, nowhere they have mentioned it is a refereed journal. That's why, though the name or the title of the journals is refereed, in most of the cases, to my knowledge, in actual sense, they are not refereed. For example, related to my subject, American Economic Review. If you go through the American Economic Review title, probably you have not seen all the qualities which are seen in others, like it is a blind review or referred journals. So, or the journal published by Royal Society of Swedish Royal Society. So, that is related to statistics, for example. So, my intention here is that we should have to read the articles only in those kinds of journals. So, then only we learn more about research, how to conduct research, and how to use and what statistical tools has to be used, when a statistical tool has to be used, and all these things are known to us only by reading the articles in those journals, not in other journals. So with these words, I end my session. So thank you for your listening from last almost 3. Thank you.